friends, today we are going to talk about linear programming problem which is called as LPP by graphical method. So today we are going to learn about maximization. Now this is our question. An airline offers first class and coach tickets. So there are two categories, first class and coach tickets. So this is category 1 and category 2. It can be, other things like chair and table, any category I mean. So it has two categories. So airline offers first class and coach tickets. For the airline to be profitable, it must sell a minimum, you can see this minimum of 25. Whenever the words are coming minimum, that means there is some constraint. So minimum of 25 first class tickets and a minimum of 40 coach tickets. So the company makes a profit of $200 for each first class ticket and $225 for each coach ticket. So this is a profit the company is making in these two categories. The first category is first class, that is $200 profit. When you sell one first class ticket, the company will get $200, and if the company sells one coach ticket, it will get $225 profit per ticket. At most means what? At most means maximum. At most, the plane has a capacity of 150 travelers. That means maximum the plane can take is 150 travelers. That is another constraint. More than 150, the plane cannot accommodate. How many of each ticket should be sold in order to maximize profits? So how many of each ticket the company should sell to maximize the profits? So what is to be decided? It means what has to be found. What is the objective of this problem? That is, I've already told you, maximization of profit. Whenever we are talking about profit, it is maximization. Whenever we are talking of cost, obviously no one wants to increase the cost or maximize the cost. It will definitely will be minimization of cost. But in our problem, it is maximization of profit, because we are talking about profit, and profits have to be maximized for a company. So what are the limitations of the in the problem? The constraints. This is the constraints part. So let us see these three categories. So what is to be decided? It is x and y. Let us assume two variables x and y. X may be first class. X is first class tickets and y is number of coach tickets which will be sold. In such a way, the constraints are met and profit is maximized. So that we have to find. Next is, what is the objective of this problem? Obviously to maximize the profit. And what are the limitations of in the problem? It must sell a minimum of 25 first class tickets and a minimum of 40 coach tickets. So this could be a government regulation, or because you have to sell at least some economy tickets so that the other people, lower income people, can travel. So there can be a legal requirement. So this is a constraint. We have to understand that this is a constraint. So this has to be done. So this is all about these three parts. Again, we are putting it this in a correct manner. X is x tickets of first class, x number of first class tickets, y number of coach tickets. Maximize 200 is a profit multiplied by x of that category, first category, and 225 is a profit in the second category multiplied by number of tickets sold in that second category, which is y, subjected to x first category should be greater than 25 or equal to, y should be greater than or equal to 40. Total number of seats x plus y is capacity equal to 150 or less. X1 and x2 should be greater than 0 because we cannot sell less than 0 tickets. Non-negativity constraint. This is what last one. Non-negativity constraint. Non-negativity constraint is x1 is greater than or equal to 0 and x2 is greater than or equal to 0. So that means the tickets cannot be negative. So it has to be greater than or equal to 0. And then the another constraints, x is greater than or equal to 25 and y is greater than or equal to 40. So this is the minimum you have to sell, and x plus y, the total capacity constraints. All these constraints are written here, and this linear programming model is subjected to all these constraints. So this is how we have to make the LPP model, and then we move ahead. And the first step is to convert the inequalities into equality. Like x greater than or equal to 25 is an inequality, and we convert it into an equality which is only equal to sign. So x is equal to 25, y is equal to 40, and x plus y is equal to 150. So we have converted this into equal signs so that it is easy for us to plot. So x is equal to 25. Now how do we plot this in the graph? X is equal to 25. So where is the 25? 25 is here in x-axis. So this line we have made because of x is equal to 25. After making this line, we write the equation x is greater than or equal to 25. So greater than will come on the left side or the right side. On the left side is obviously it is less than 25, and greater than should be always on the right side. That's why I have highlighted this part. Now this is the part which we have highlighted on the right side of the line because equation says x is greater than or equal to 25. So this particular part is done. Now the next point, y is equal to 40, y-axis is this one, this is the y-axis, and y is equal to 40 is this point, and we make this line y is equal to 40. But we also know that y is greater than or equal to 40. Actual equation is y greater than or equal to 40. Now tell me on this line, greater than or equal to 40, equal to is 40, this line has been made. Greater than will be where? On the top of this line or on the bottom of this line? Obviously bottom is less, so we have to make on the top of this line, and we make this particular region, and we highlight this particular region. So this is what all about. This is the another region. So this is the second region we have highlighted. Now we go to the next one. The next constraint is x plus y is equal to 150. So when there are two variables, first we equate x, we make x to 0, and then we get y is equal to 150, and then we say y is equal to 0, and then we get x is equal to 150. So one variable we make 0, we get the other value, and another variable we make 0, we get the next value. So y is 150 and x is 150. So we put this. So in x-axis, this is the y-axis. Y-axis 150 is here, and in x-axis, this is the x-axis, and we write here this one. This is this one, not here. This one we make it here 150. This one, 150 and 150, and this particular line is made, and now it says less than or equal to 150. Less is always, it will be always at the this side of the line because this is the lesser value. On the other side it is higher. So now we highlight all these regions, and we see where these three regions are overlapping. So this is the region where it is overlapping all the three constraints. This is the region we are looking at, and this region is called as feasible region. Feasible region. In this feasible region, any point in this region will be fulfilling the three equations or three constraints, any point. But our question is not that what points, there are unlimited number of points here. Sense not three, this is a three vertices, and what I'm trying to say three is there are 3 points, and of these 3 points, which one will optimize the solution? When we say optimize the solution, we say when which point will maximize the profit. So it can be A, it can be B, it can be C. So how do we find that? And why we have taken A, B, C? Because obviously the points will be in the vertex, either here or here or here, because these are the limits. So these three limits, always in the vertex the solution will lie, and now in these three, which one will is the solution we have to find. So how do we do that? So we input the value of this A, B, C in the maximum function. So we have done that over here. We have put 25 and 125 over here. We have put 25 and 40 over here, and we have put 110 and 40 over here. And then we find the profits. These three profits have come. Out of these three, the maximum is this one, 33, 125. So we say that point 25, A25, 125 is the solution because it maximizes the profit. So the point A 25 and 125 maximizes the profit. Therefore, we conclude that the airline should sell 125 coach tickets and 25 first class tickets in order to maximize the profit. So thank you for watching this video.